Recording.
Get on the notes.
All right, so are we ready to start chapter 4?
No. Yes.
So let's think about where we have just come from. Beginning of this whole entire course, we talked about the foundations of geometry. So lines, line segments, angles, shapes. Then chapter 2 is all about logical thinking. How do we do our if-then statements? What's the converse of if-then statements? How do we look at patterns? Then chapter 3, we looked at specific types of lines, which were parallel and perpendicular lines. So now for the rest of the course, we're going to be looking at, well, what happens when we put line segments together and form shapes. Chapter 4 is all about triangles. We're going to be stuck on triangles all the way up to chapter 7. So chapter 4, chapter 5, chapter 6, and chapter 7 are all specific to just triangles. And then we move to quadrilaterals. We add another side, so from 3 sides to four sides. Then we go to circles. Okay, so that's kind of the progression now that we're going to be making as we continue throughout the year. So today should be a fairly easy section. What do we talk about when we're talking about triangles? Well, the first thing is, how do we classify them? So I think this is already there. You don't have to fill anything in for yourselves. So a scalene triangle is a triangle that has 0 congruent sides. So maybe just down here in the blank space, you want to put 0 congruent sides. An isosceles triangle has 2 congruent sides. Not possible.
3.
An equilateral is 3 congruent sides. Okay? So when you classify a triangle, you're going to pick one of these, which is your classification by sides, and then you'll combine it with classifying it by its angles. So in an acute triangle, how many acute angles are there? Good, so we have 3 acute angles. In a right triangle, how many right angles
1.
would you have? Why can you not have 2? It would be a square, because you can only have how many degrees inside of a triangle? 180, right? And if you had a 90 and a 90, right there was 180, and you can't have a 0 degree angle, right? In an obtuse triangle, how many obtuse angles can you have?
3. 1.
Just only 1 also. So 1 obtuse angle. An equiangular, what does equiangular mean? So you have 3 congruent angles. Do you remember what we called it when you had all congruent sides, all congruent angles? Started with an R, end it with an R, had a G, regular, right? So regular polygon is one that has both equilateral and equiangular. Remember we talked about that? Okay, so for the first example, what would you classify triangle 1 by?
Right triangle.
It is right, because it has a right angle. Right isosceles.
Why is that isosceles?
Because it has 2 congruent
Yes,
sides
right triangle.
here. Right, but you pick one from the top, one from the bottom. So you make a combo out of both of those.
We have to, so we're going to prove these?
No, not today.
No, so the next one, that's eventually.
Eventually we're going to prove congruent triangles, is where we're going. Number 2, equilateral. What about the angles?
Equiangular.
Well, do we have that for sure?
Yes.
You have arcs inside the angles?
Sure.
Equilateral. Acute.
Acute.
Wait, so how is...
These arcs inside would need to be there to be able to...
Easy.
Number 3,
Bless the sun.
what type of angle?
I'm not even going to answer this one.
I got it.
It is scalene. Do you have 3 acute angles in there? Do you have a right angle?
No.
Do you have an obtuse angle?
Yes.
Yes. So obtuse, scalene. Okay. All right, so can you classify a set of triangles?
No, I guess not, because they're all wrong.
All right, let's go through a few more then. This is not on here. Just going to quickly make a bunch of triangles. Is everybody okay? I can erase that? All right, how would you classify this triangle?
Right triangle.
But you need it by its sides, too.
It's an isosceles.
Right isosceles.
There's congruent sides.
No, there isn't.
So it'd be
No, there's dude, there's no lines.
right scalene would be the correct answer. How about this one?
That's just a scalene acute.
Isosceles and the angle?
Acute.
Acute. Good. What about this one? Isosceles, what's the angle?
Obtuse.
Obtuse. Good. What about
What's this?
Equilateral, that's also, what's the word?
Equiangular.
equiangular and equilateral? Good. What about that one?
17th century cup.
Scalene.
Sure.
Buzz.
I'll make it more obvious. I was trying to make that obtuse up there. Scalene obtuse? Yeah? So everybody got this? Do I need to do more?
No, I think we'll be good.
Okay. So now, we need to get to the triangle sum theorem, which you guys already know this. The sum of the measures. So the sum of the measures of the interior angles of a triangle is 180 degrees. Did we know that?
Yes.
All three angles add up to 180? So this should not be new material. So once you have that, flip onto the back. So using the triangle sum theorem, can we solve for x?
I believe, yes.
What would you do?
What you have to do is base times height.
Nope, we're finding the third angle.
Space times height.
Oh, I was thinking the area of the triangle.
So 25 plus 120 plus x equals 180. So that gets me 145 plus x equals 180. So x is equal to 35.
L-E-S-T-A-L.
D. That's 35.
35 plus 145 is 180.
Yeah.
Okay. Can I move on? Next one. What's your equation going to be here?
2x plus x minus 6.
2x plus
No,
x
no,
minus
there's a right
6
angle in there.
plus 90 equals 180. Remember, all three angles add up to 180. So you got to make sure they're all three. So 3x plus 84 equals 180. So 3x equals, what is that, 96?
Divide by 3.
So 32.
I hope we can hear that.
3 goes into 9, 3. 3 goes into 6, 2. Questions yet?
Really? It's 3? I really thought it was 27.
All right, so now the next example, we've got two triangles in our diagram.
Yeah, that's not.
Excuse me. So, let's first focus on the left triangle over here. Do your math, figure out what x has to be on that left side triangle. Go.
180.
Well, they all will add up to 180, so what will x have to be?
Well, you can just do 65 plus 39 equals 180.
Yep, so do that.
Times like what? Wait. So we gotta find the first one, and do we
Plug it into the other one? Is that what you said to do? I didn't know.
How did you get that?
I did 39 plus 65, and then that is 109, and then I
Yeah.
took 180 minus 109.
How do you get
That's 171.
Don't you,
I mean, it's 71, sorry.
I don't know.
No, it's not.
What are you thinking?
180 minus 109.
So what do we get? 76 for x? So now let's look at x and y. What type of angle? 76?
Wait, it's 76.
No, it is not.
Adam was right.
65 plus 39 is 104.
180 minus 109. That's
104. 9 plus 5 is 14. That should be a 4, not
Oh,
a 9.
it's my really awful handwriting that
Yes,
messed me up.
that would be the case. What's the angle?
Dang it!
What's the angle relationship between x and y?
They're
letters. 180.
They're a linear pair.
Letters.
So x plus y should equal 180. That's what we just said.
Because X, Y, and Z.
X we just said was 76.
Y is 104.
104.
Bow down to me.
No.
Okay.
Alright.
Okay. So now can you find z? If y is 104, how would you find z?
104 plus 21.
Yeah, good. 104 plus 21 plus z equals 180. So that gets us 125, guys. Plus z equals 180. 180 minus 125.
Idiot.
Guys, be nice, please.
Oh, you're setting the equation. I
Yeah.
thought you were actually saying
Yeah. No.
What does that get us? 55?
Yes.
About 20 feet.
Okay, so before we get to our last theorem in this section, is everybody okay with this problem?
Yeah.
What do you notice about, if I were to, can I erase all this, just get rid of the, okay. So now what I'm going to do is, give me a second. If we were to ignore all of this and just focus, we said y was 104. What do you notice about the relationship of y, the 39, and the 65?
Well, yeah,
It's
together.
It equals 180. doesn't it?
or it's
No.
the interior.
That's stupid.
What's 65 plus 39? 104.
Yeah, it's in my
Is y in the interior or the exterior of that left triangle? Is y inside this triangle or not? It's outside, so it's the exterior. So your exterior angle is equal to the sum of these two interior angles.
Yeah.
Does everybody see that? So that's where we're getting. If we look at what did we say x was?
76.
X was 76. And we said z was 55. Is x on the interior or the exterior of this right triangle?
The exterior.
Exterior. What's 55 plus 21?
76. That's whack.
Isn't that crazy? How that works like that? So the exterior angle theorem states the following. Write this down, please.
Wait, can you explain that?
Well, that's what we're getting to right now.
what I'm not.
So write this. The measure
Identity.
of
20
an
feet.
exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent, fancy word right there, so the two non-adjacent interior angles.
Oh, God bless you.
So remember, adjacent means right next to.
Yes.
Kelsey and Bailey are adjacent to each other. Joe and Cam are adjacent to each other. So non-adjacent would be people who are not right next to each other, right? So this only works when it's the non-adjacent interior angle. Because if we think about it, let me write it on here. Think about your triangle again. Do I have space above? Yeah. Just watch. Don't write this. So interior, oops, let's get a different color. So interior, 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 right? Those are your three interior angles. Does everybody see that? Here is my exterior angle. Let's do that in yellow. Can everybody see yellow? Right there is your exterior angle. Would dot 1, 2, or 3 be the adjacent interior angle to the yellow dot? 3 would be the adjacent one, right? Does everybody see that? So 1 and 2 would be the non-adjacent.
So does that make 1 and 2 adjacent?
Yes. Okay. All right, so let's go ahead and apply this. Angle 1 is an exterior angle. So the measure of angle 1 is going to be equal to the sum of the two non-adjacent angles, which would be 40 and 30, which is 70. Oops.
35.
Could you get there the long way? Sure. You could do 40 plus 30, which is 70, and then find the third interior angle, which would be 110, and then find the supplement of it, which would get you back to 70. Okay, so that's the long way to get there, but this is the short way. How would you do B? Exterior angle is 113 is equal to 70 plus the measure of angle 2. So subtracting 70, that's us 43.
Oh, 47.
3 minus 0.
35.
Now can we put algebra into the mix?
Hey, yes, fine. Let's do it.
All right. What's your exterior angle up here? 2x minus 5. Does everybody see how that represents the exterior angle?
Yes.
Will be equal to what plus what?
70.
Plus.
X.
Good. How do we solve that equation?
Well, you take 5 and add it to 70,
Okay.
which makes 75. Then you take x and you subtract it, which makes it x equals 75.
Good.
I'm a
This-
freaking genius.
Do I just need to solve for x?
Thank you. Welcome.
What does it tell me to find in the directions?
JKM.
So what do we need to do?
I don't know.
I mean, it's just
What is the measure of angle JKM?
Good.
JKM is 2x minus 5.
Uh-huh.
What did we say x was? X was 75. So we're just substituting it back in for x.
Why is the L there?
LSTR.
Huh? So 2 times 75 is 150 minus 5. So
I
145,
see L there, but it's not anywhere in the equation.
because we don't need it.
What is L?
Add the picture.
L is the vertex right here.
What is ESP?
It's not needed until the very end.
It's not needed at all.
Yeah.
It's just labeling it.
You didn't know.
Questions? All right, what I want you to do